Hello friends, today I am going to cover an important topic, that is basically continuous time signal. So what do you understand by continuous time signal? This is very important, fundamental point of view. You must understand this concept because you can apply this concept in maximum problems. First of all, you should know which signals are continuous time signals and which signals are not continuous time signals. Actually, with respect to time, if you consider the signal having two classifications, you can say continuous time signal or you can say discrete time signal. So first of all, here I am going to cover the concept of continuous time signal. So what is basically continuous time signal? Now let us discuss continuous time signal. Continuous time signal. So whenever you are discussing any signal, that means you just consider the time axis extends from minus infinity to plus infinity. That means suppose this is your time axis. You just think suppose this is your signal axis. Because actually whenever you are discussing continuous time signal, just the representation you can use, that is the x is a function of time. Here t, I have told in the last discussion, t is the independent variable and x is the dependent variable. Now what happens, whenever you discuss this x is a function of time, that means you just consider this is your time axis, this is your x axis. X means x is a function of time. Now this is just considered as the origin, that means time 0 and x value is also 0 at this particular point. See here what happens. So now this is basically your time axis. I have told whenever you are discussing x is a function of time, that means t is independent variable, x is dependent variable, and always independent variable is taken on abscissa, dependent variable is taken on ordinates. So that means you are getting a plane, just like a plane. So this is t axis, this is your x axis. Now here you just consider time is from minus infinity to plus infinity. That means this is suppose minus infinity, this is suppose plus infinity. Actually plus infinity is somewhere there, minus infinity is somewhere in this side. So but actually let us consider this particular point is minus infinity and this particular point is plus infinity. Now this is your origin. Whenever you consider the time, that means you have to consider the entire time points over the entire time axis. That means this point, this point, this point, this point, this point, this point. Every point you just consider. Every point you just consider. These all points are consecutive. These all points are not separate points. These points are continuous points, you can say. Every point you just consider. Now, for each and every point, from minus infinity time to plus infinity time, if the signal value exists, that means you can say that the signal is defined for each and every time point from minus infinity time to plus infinity time. That means you can say that the signal is said to be continuous time signal. See here, suppose actually I am having this signal. This is the plot of the signal. So that means suppose you just consider this time. What is the value of the signal? Suppose I am saying yes, the value of the signal here is 0. Suppose this time I can say the value of the signal here is 0. That means any time you just consider, you can able to say the value of the signal. Signal value you are saying, yes, this is 0. 0 is a value. Suppose actually this time, you can say the signal value is 0 because 0 is a value. This time, signal value is 0. This time, signal value is 0. This time, signal value is 0. Any time you just consider, you are saying the signal value is 0. And you know, 0 is a defined value. This is not actually undefined value. Now let us consider this point. This point means this point over the time axis. That means you just consider this time. At this time, the value of the signal is this. This is basically the value of the signal. This is your value of the signal. At this time, this is the value of the signal. That means any time you just consider, you can say the value of the signal. The value of the signal exists in this plot. So that means each and every time you can say the value of the signal. Hence you can say the signal values are defined for each and every instance of time. This time defined, this time defined, this time defined, this time defined. Defined means you can say the value. Defined means the value exists. Whatever the value doesn't matter, but a value exists. Okay, so that means in this mark, this particular type of signal is known as continuous time signal. There are so many examples of a continuous time signal. Now just mark, suppose actually this is the signal. This is your time axis. This is the origin. This is your xt. Now this signal is basically continuous time signal because you just consider the time from minus infinity to plus infinity. Minus infinity, you are coming from minus infinity. Just think, whenever you are discussing a signal, you just think that you are coming from minus infinity time and you are going towards plus infinity time over the signal. Now what is my signal? My signal is this, you are coming from minus infinity. So my signal is this, that means you are moving over the signal. 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 You are moving over the signal and you are going towards infinite time in this manner. So this is basically the signal, and any point you can assign the direction of the signal in this way. That means you just think that you are coming from time t is equal to minus infinity and you are reaching at t is equal to plus infinity. Accordingly, every point you can assign the direction of the signal. Anyway, so whenever you are moving any point, the signal having the value that you are capable to say. That means you can say this time value is 0, 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 this time signal having a particular value, this value, this time signal having a particular value, this value, this time signal having a particular value, this value, this time signal having a particular value 0. So any time the signal having a single value, particular value, so therefore this signal is also continuous time signal. Okay, so now whatever the consideration you have, suppose you are having another signal, let us discuss, and I am saying that from this to this signal exists. Signal this to this exists means if actually within a particular range, suppose this range, suppose this is t1, this is t2. Now within this range, suppose for each and every point signal value exists. This time point exists, this time point exists, this time point exists, every time point exists, every time point between this t1 to t2 range exists. That means you can say that the signal is exists from minus infinity to plus infinity. What does it mean? You can say at this point the value is 0. You can say, because within a particular continuous time range, if it is exists, you are saying that it is existing from minus infinity time to plus infinity time. That means this signal is basically known as a continuous time signal. So now I can draw actually so many signals, and you can say that yes, this signal is a continuous time signal and this signal is basically not continuous time signal. Suppose actually let us consider this particular signal. So this signal you can say which signal? Continuous time signal. Because every time from minus infinity to plus infinity the signal value exists. Signal having a particular value, signal having one value, signal value is defined each and every time from minus infinity to plus infinity. So therefore this signal is a continuous time signal. Similarly, whatever the plot you have, suppose this signal is a continuous time signal. Now suppose actually this signal is a continuous time signal. Now suppose actually this signal is a unit step signal, that is basically continuous time signal. Now this is ramp signal, unit ramp signal. Suppose you are having slope is 1, slope is equal to 1. This signal is also continuous time signal. Now here actually we are taking the height is 1. This is your unit step signal, that is also continuous time signal. It is basically denoted as UT. It is basically denoted as RT. Now all these types of signals are continuous time signal. But mark the important concept here. Whenever we are discussing this unit step signal, at this particular time 0, the signal having many values. Not a single value you are getting for the signal, because at 0 the signal value may be 0, maybe this, maybe this, maybe this, maybe this, maybe this, maybe this, maybe 1. That means at time t is equal to 0, the signal value you can say 0 to 1 any value. So therefore at this particular time 0, the signal is not properly defined, but still you are saying this is continuous time signal because other points it is continuous. This particular point it is not continuous. Okay, so that is why though it is not actually continuous time signal, we are assuming that it is continuous time signal, and at the time t is equal to 0 we are taking the average value. What is the average value? Initial value 0, final value 1, 0 plus 1 by 2. This is basically the average value for this unit step signal. So anyway, so this signal I am considering that is a continuous time signal, and this signal you just mark every time point the value exists, this time value exists, this time value exists, this time value exists, this time value exists, every time point the signal having value and that value exists, that value defined. So therefore this signal also you can say that continuous time signal. So that means, what is my conclusion? Whenever we are discussing a signal, any signal is just consider from minus infinity time to plus infinity time if signal values exist. That means signal value defined for each and every time instant from minus infinity to plus infinity, then that particular signal is basically known as continuous time signal. That means here there is a predefined set, and within the predefined set all the time points from minus infinity to plus infinity exist. So that is a predefined set. Now if all the time points for the signal exist from minus infinity time to plus infinity time, that means you can say that that signal is basically known as continuous time signal. What does it mean? So let us consider this is a set. So minus infinity to plus infinity time, there is a set. This is a set of time points. Now how many time points? Infinity time, number of time points. This time point, this time point, this time point, this time point. All the time points are within a set, suppose. Now whenever we are discussing signal, in the signal all the time points must exist. What does it mean? So each and every time point the value of the signal must be there. It is actually the meaning, and here if you understood this particular concept, that means you can say that maximum problems you can easily handle, and if you clear in this particular concept continuous time signal, then automatically discrete time signal will be very easy. How to define discrete time signal, how to deal discrete time signals. So before dealing with discrete time signal, first of all you must know what is the definition of discrete time signal, and this definition I will discuss in my last video. Anyway, these particular signals, whatever the signals I have drawn here, all these signals are basically known as continuous time signal. And if you want to represent the signal, here you just mark, this particular case you just mark. Here at 0 the signal is undefined, because signal having many value from 0 to this. Suppose this is 1. Here also it is undefined, because signal having, suppose this is your time t1. At t1 the signal having many value from this to this. So therefore at some particular time instance this signal is not defined, but other many time instance, other all time instance the signal values are defined. So therefore this is assumed that continuous time signal. Anyway, so in my next discussion I will discuss what is basically the definition of discrete time signal. Now let us discuss actually this xt in a mathematical form. Suppose t square, this is continuous time, xt is equal to t. This is the mathematical form of a representation of this continuous time signal. Xt is equal to t square plus 2t plus 5. Any equation just write based on t, that is basically known as a continuous time signal. Now whenever we are discussing xt is equal to t for t greater than equal to 0 and it is equal to 0 for t less than 0, this is nothing but the definition of a ramp function, and this ramp function is basically continuous time signal, and this is the mathematical representation of the ramp signal, which you can represent in this manner also. Xt is equal to tut, so that means this is also continuous time signal. So many equations you can represent for continuous time signal. Any equation based on t is basically continuous time, that is basically the representation of continuous time signal. So thank you very much. In my next video I will discuss what is basically the discrete time signal. So these are the fundamental things. After discussion of these fundamental things, the signal system will very easy. Thank you very much.